So let's look at another small lemma about sheaves. This one will turn out to be quite useful when we introduce the concept of an Espace Étalé. But first we need this lemma. So let X be a topological space and let F be a sheaf on X. Then for every U, so U is an open subset in X, then for every U in X open, the map phi, which maps Fu to the union of the Fx, where X ranges over all X in U. And what this map does is it maps a section F, so an element of Fu, to such a tuple of germs of F at the points X, where again X ranges over the elements of U. This map phi is injective. This is what we want to prove. So this is not hard. Assume that we have two sections, so two elements in here, F and G in Fu, such that phi of F is equal to phi of G. So F and G get mapped to the same tuple of germs over here. So this means that if you think about what the germs mean, they determine what the sections look like locally. So this means that for every X there is a Ux. So for every X there's a small open neighborhood Ux, such that F restricted to this maybe very small open neighborhood Ux is the same as G restricted to this small open neighborhood of X. But now the Ux form a cover of U, because for every point X we have such a set Ux where F and G agree. And this means that F and G have to be the same. To reach this conclusion, let me quickly remind you of this first condition we had for schemes. I mean for sheaves. It said if you have an open subset U and you have a cover of U by open subsets Ui, and you have that elements of Fu, F and G agree on every of these open subsets that form a cover. So F restricted to Ui is equal to G restricted to Ui for all Ui. Then F has to be equal to G. This was the first of the two conditions that made a pre-sheaf into a sheaf. And assuming this, as we do here, because we are assuming that we have a sheaf, so we have this condition, we can conclude from the fact that the Ux cover U and that the sections F and G agree on these Ux, we can conclude that F is equal to G. And this, of course, concludes the proof of this lemma.